I'm going to attempt to make a quick video over the issues I saw in the homework from page 294, number 3, and then 6 through 8. Starting at number 3, there was the problem about genetics. Suppose a married man and a woman both carry a gene for cystic fibrosis, but don't have the disease themselves. According to the laws of genetics, the probability that their first child will develop cystic fibrosis is 0.25. Part A says, explain what this probability means. Many of you just wrote there's a 25% chance that their kid will get cystic fibrosis. This is incorrect, and here's why. We've now learned about the law of large numbers, and we also know about variation in statistics. What I'm looking for is I'm looking for a large sample size. So I'm looking for you to say something like, if we look at many families, where the husband and wife both carry the gene. I'm not going to keep writing, just so you can get the point here. I'm also looking for you to say in approximately or about 25% of these families, their firstborn will develop cystic fibrosis. So again, what's the takeaways here? The takeaways here is if we look at many families, law of large numbers, large trials, or many trials, the next one is about 25% will develop, and you're setting up the same situation that they say. So the married men and the married women both have to carry that gene, okay? Part B says, why doesn't this probability say that if the couple has 4 children, one of them is guaranteed to get cystic fibrosis? Well, 4 is a really small sample size, right? So let me just kind of sum it up. In order for the probability to be closely reflected in the sample, we must have a large sample size. Again, going back to that law of large numbers. So let me repeat myself. You're looking for, if we look at many families in Part A, about 25% of this should happen, okay? It's not just the probability of blank is this. That's not how we answer it. Number 6, Part A. Part A says, now what's your estimate for the probability of heads if you do that? If you actually did this problem, the answers will vary, but we would approximate that the probability that it flips heads will be somewhere around 50%. If you do it the same way every single time. So if you actually did it, you might get 11 tails, 14 heads, okay? Something like that, something similar. How could you get a better estimate? So closer to 50%, you're not going to get 50% exactly necessarily. But if you wanted even closer to 50%, you would increase trials. Number 8, keep tossing. The figure below shows the results of 2 different sets of 5,000 coin tosses. Explain what this graph means about chance behavior in the short run and the long run. And again, hopefully the takeaway here is, I don't think I can make this bigger, is in the short run, right here, there's lots of variation. In the long run, the variation settles down and it approaches what we believe is the truth. Whoops. It approaches what we believe should be the true theoretical probability, law of large numbers. Thanks for listening. I hope this made sense. If it doesn't make sense, the biggest issue that I saw was number 3. So re-listen to that again about the keywords I'm looking for and let me know if you have questions. Thanks.